these elements of the electronics. So let's say we have a river flowing, and the volts is like the amount of water flowing. The amps is like the velocity that the river flows, and let's say resistance. If you want to build a wall that is preventing from the water from going on, then that could be your resistance or anything related to restricting energy from flowing. Very important, following up with this topic. So in electronics, it's very important, the Ohm's law, which this structure you're going to see very often. You can see that the volts is given by the amps times the ohms, which is basically the current times the resistance. We can get the voltage. And that formula, actually, those formulas is just the same but flipped, right, as an equation. And in that way, you're going to see now that it's very important to calculate the resistance that we need, which is given sometimes by the, we have the volts that we need for our component. You're going to see that we have the information of the electronics board, what energy is giving, which is by default is going to be 5 volts, we're going to see now. And in that way, we can calculate the resistance that we need for our components. So we're going to kind of apply it now. So as you can see the formula, so the resistance that we need for a particular component anywhere is given by 5 volts, which is the constant that we know that for sure Arduino is going to emit 5 volts, minus the target voltage of our component. For example, actually we're going to see it in the next section. And that's divided by the current that we also have it, that is generally both part of the Arduino and part of the components. So it's very important to know that the Arduino Uno board, that's the one that we're going to be using. There are a lot of Arduino models. There are some others that are more complex, that are built in for more complex tasks. And the second point is the electricity current the component needs, and the voltage the component needs. So that's very important to keep in mind. And we're going to do actually a quick exercise, kind of to get started with the Ohm's law and trying to understand how this electronics kind of works. So if you guys can calculate the resistance needed for an LED, which is going to be very, you're going to see very often that we're going to use it. And based on those variables, what you guys think the resistance is. The number. If you guys can calculate, and then you tell me, and then we reveal it. $15, you calculated? What was the calculation again? So like in the numerator, what do you have?
In the numerator, I have the current, right?
No, actually that's the voltage.
Oh, that's a volt?
Yeah, the V corresponds with the voltage.
Oh, the denominator is I, isn't it?
That's the current.
That's the current. I 0.020
Yep.
on the denominator, right?
Exactly, 0.02.
5 minus 2, which is 3.
Exactly.
3 divided by
0, 0.
0.00.
It's actually 150.
Is it 150? I think I did something wrong. Oh.
You got it right now?
I got 0.20. I did it with 0.20, my bad.
Don't worry. Yeah, that can happen. But make sure you measure in amps and not in milliamps, because sometimes when you, for example, look at some instructions on how to set up a circuit, sometimes it's in milliamperes because it's easier to say it like with integers, right? For example, here you say just 20 milliamperes, but for the formula you need the 0.020 amps. So make sure that you calculate in that way. You said something?
What if I calculated that wrong? Like, what would have been the consequence?
Okay, so for your case, what do you think it will happen?
Well, too little resistance means too much of everything else going through.
Too little resistance, exactly. So basically, you might burn it.
Yeah.
But I don't think with that example, like particularly, you're gonna like burn it, because it might work for some time, but in the long run, it's gonna fry the component. But yeah, so it's always better to add more resistance than like,
None at all.
yeah, exactly. So yeah, and as you can see, so it's 150 ohms. That's the like specific calculation for an LED, which actually it changes from color to color. That's very curious because they have different like energy structure in the internal part. But what is very important to know here is that although it's 150 ohms, you're gonna see that we're gonna work with 220 ohms because actually we don't have 150 ohms. But why is that? Because 220 is a standardized like resistance that is very used in electronics in general, and it's very common that for some calculations we're not gonna have like the particular exact resistance. So we need to find like the next closest to it. In this case, as it is 150, it's gonna be 220 ohms. So you're gonna see that we're gonna be using 220 ohms for the LEDs. You guys, any doubt till now?
It has to be above 120.
Always.
Always above.
Always above the calculation. So you need to start with that formula, which, because sometimes for LEDs you can just Google it and probably gonna say 220 because it's widely used. But for example, when you are researching new components or you are working with electronics that are not very like documented, you need to follow the formula. And that's why it's a good practice to get started with the exercise of calculating everything. And yeah, make sure that you find the next resistance above that calculation. Always. Good question. Okay. So moving on, actually what you kind of said. So what are the risks of, in this case, of course this is a little bit like exaggerated on purpose for the workshop, but because Arduino is like very, as it is user-friendly, so except unless you're like doing something else, it shouldn't happen anything, right? Because it has very low amps and very low voltage. It's not very like harmful for the human. Just if something goes wrong, you're gonna be fine. Probably gonna feel something in your finger, but it's just that. But in this case, it's very important because as robotics gets more complex, so the structure gets more complex. So it's very common to see there are different types of circuits. You have parallel circuits. You have like different types of like circuits that have multiple components within the same like energy flow. And you need to make sure that, because sometimes the energy sources are very, very powerful. And actually, some of them are very, very harmful for the human. So make sure that always is a good practice if you guys start doing it now, although it's nothing is going to happen, that you guys unplug the Arduino, do your stuff, and then when you test the code again, you plug it in again. I know it might sound tedious, but trust me, it's for your safety. Because you might get into trouble in the future if you like delve into more energy consuming components. So, and that's actually very important, very, very important. So let's start using our Arduino. I'm gonna start like explaining the basic Arduino hardware and the I/O, which stands for input and output. So, and this is very important because for the structures, we have two main like sort of categories that we're going to be using in Arduino. One is if the component is going to be either input or output, and also we're going to see the distinction between digital or analog, which analog we're going to see in the next workshop actually. Today we're going to start with digital and output. The next workshop we're going to do digital input and then combine with analog. So following the structure, so we have these digital pins. Here we have this little tiny red button, which is the reset switch. The USB connector is basically where you plug in your Arduino. Then we have a lot of mini like components that we are not interested in at this time. But if you guys are interested, so this TX, RX LEDs, we have here again 2 pins that are like used. The 0 and 1 are used for communication and for like serial protocols. For example, if you want a robot that uses geolocalization through GPS, or you want Bluetooth, or you want Wi-Fi on board, then you're going to be using those pins. But for now, we are going to be interested only from 2 to 13. And we're going to be using from here the power sources, which actually are not like signal here, but those are very important. We have like different energy sources. We have the 5 volt. We have the 3.3 volt, which also is widely used, but for this workshop we're going to be using only the 5 volt and the ground, which in simple terms, where the 5 volt is bringing the positive energy, right? And the ground is going to be connected for our negative pole components. You're going to see it very often. And delving more into the digital pins and the digital signals. So it's very important to note 2 things that happens in Arduino when programming Arduino, is that we have, on the one hand, we need to see what's going on in the Arduino IDE, which is basically our software which we're going to be using to code, and then how that is translated into reality, into the physics world with our Arduino. So for example, in this case, the digital signals or pins are only used with binary signals. In this case, it's going to be either 0 or 1. And in Arduino IDE, you're going to see it as well with like as low and high being 1 and low being 0. And how do you guys think this is translated in electricity? Like if I have a 0 in the Arduino IDE, how much voltage is going to be? 0, yeah, exactly. And then we knew that, as we did in the previous example, we have the 5 volt here. So why? Because we know that the constant most of the time is going to be 5 volts, at least what we're going to be using. And if you see here, high, let me use the laser pointer. So we have the high here, and then the 5 volt here. Why? Because the high is going to be full power. And this is translated in electricity as 5 volts. That's in our case, for our Arduino board, right? But maybe in a different embedded system, you might use high for 15 volts or whatever amount of energy. But for the calculations, we're going to be always using 5 volts unless we use something different from here, like the 3 volt, which is not very common. And again, where to find the digital pins? So are going to be labeled from 2 to 13. Make sure you connect the digital components that we're going to be using in those pins and not somewhere else, because if not, otherwise it's not going to work. And as you saw, for example, in the intro session last Monday, we made blink the built-in LED, which is controlled by the digital pin 13. So I don't know if you guys remember that with the code, we did like sort of digital write, LED built-in high. Remember that it was capitalized, LED built-in. But it was because behind the scenes, what Arduino is doing is it defined a variable called LED built-in, and it's assigning the number 13. And now you're going to see why it makes sense, because we're going to start coding it and actually doing by ourselves. Let me move on with this. Okay, so let's start with our first project. First, I want you guys to get some, like, let's do 2 to 3 minutes to get started with this circuit. We're going to just start blinking instead of the internal LED. You're going to start actually interacting with external components. And make sure you grab these components. We're going to need the Arduino, as always, the breadboard, that is going to be a constant. If you guys have a red LED, or you might get something else. And make sure this time you get a 220 ohms resistor and 2 jumper wires. Let me get you one kit. What's your OS? What is your OS for the computer? Like Windows? What is? Windows 10? Oh, great. Okay. So you don't need a converter. Well, I think this has the Arduino, yeah. You're welcome.
Question.
Yep.
So, why does it specifically work when the red wire is on 13, but when I switch it to 11 something, it doesn't?
Because probably it's not matched with the code.
Oh,
Hopefully you're going to see now why that happens. Yeah. But I don't know what resistor you're using there. I didn't see. Which one? That's a problem, man. Yeah, because in the long run, probably that LED is going to, I mean, not for now. It's not a problem, but if you're working for a company, you don't want to like burn their components, right? Because it might be much more expensive than an LED. Let me see. Okay, so guys, please starting like setting up this circuit and make sure you connect. So this is very important to note. For the LED, by the way, do you have a computer? Oh, no, never mind. No. Make sure, so this LED, for those that don't know, this is the LED or little light here. So we have like a longer leg and we have a shorter leg. Make sure you connect the longer leg to the pin, to the number, to the digital pin, which in this case we're going to be using pin 11, right? Make sure you connect pin 11 first to either pole of the resistor, because it's bipolar. You don't have to worry about negative and positive sides. And make sure that resistor is then connected to our positive, like longer leg of the LED. And very important to note how the energy flows here in the breadboard. So once you connect it here, like for example from 11 to here, then it's feeding the entire column. Then the resistor here is taking that energy and passing it by through the next column, which is this one. And then the LED is being fed in this pole. And the same thing with the ground. So connect the ground, which always goes to the negative pole of the LED, which in this case is going to be our shorter leg of the LED. So make sure, again, the shorter leg is the negative, is connected to the negative part, the ground pin, which is the G and D pin. Let me know if you need help with the circuit or anything, any question. Yep. You need help or a question? Okay.
You said the resistor on the larger side?
Yeah, exactly. The larger leg.
It's like where? Here?
You could, I mean, you should, where did you put the larger leg?
Here.
Yeah, so on the left, right?
Yeah.
Okay, so make sure you put like the resistor.
Here?
Exactly.
And then where do the other leg go?
And then whatever you put the, like you see the pin 11, there that is connected to the one part of the resistor, like one pole.
Okay.
So whatever you put in the same column of from the pin 11.
Which pole? The positive pole?
For the resistor, it could be, no, I mean, you could put it, for example, let's say. So you could put it like here, right? Or anywhere, right? Let's say you put it there, let's say.
Okay.
And then you get a shorter wire. You connect the 11.
This pin 11 is right here.
Yeah, exactly, 11. And then you connect it to that pole of the resistor.
The positive pole?
I mean, you should do it here. Like in the same column. It could be anywhere within the same column. Is that in the same column?
Yeah.
Actually, no, I think.
Oh, you mean the same?
Exactly, same column. Yeah, it's column wise.
Those are rows, these are columns.
Yeah.
Yeah, sorry.
Don't worry.
We'll put the negative one.
And that the ground, check which is just the same.
Easier if I could have it over
I don't know
here.
why this is here.
I think I activated the keyboard right here.
Oh.
So I don't know how to switch it out.
Oh, okay. Oh my. I don't know what happened.
Is there like a way to get this?
Do you want to switch to other table?
Sure.
Yeah, I think it's going to be easier if we do that. Thank you.
How do you use it?
Huh?
¿Cómo lo ve? Estoy ahorita
Um,
poniendo el
So, pin 11,
round.
I think it's fine. This is the larger leg of the LED?
Let's see.
No, actually, it's the other. Yeah, just flip it. Exactly. And the way that you told me it should be fine. Then you connect it.
Here on 11?
In 11, yeah.
And then?
And then the
other one?
positive. Exactly. You're feeding the positive side with the digital pin.
Okay. And not, it can, the other one, the other leg can go anywhere?
The other leg, what do you mean the other leg?
The other leg of
For the LED?
No, the resistor.
The resistor, yeah, it should be like the same column of the positive, like the larger leg, right?
Here? So.
Like it should
Oh,
be
it should be then here.
exactly, yeah. Then I think it should be fine. You guys are ready with the circuit, or you need help? Yep.
This, right?
Let me see. Yeah, actually, there's one leg that is not being fed.
Where?
I think, take a look at it. Like, there's one column that is literally
Oh,
empty.
wait, so I move it up?
Yeah, depending on,
'Cause
wait,
on
so.
there it says that it's.
So this is like the shorter leg, right?
Yeah.
This one. It's going to be connected only like column-wise,
I see.
this.
I see.
And then the resistor, it acts like a bridge.
I see.
Yeah. Exactly. Yeah. Okay, let me see. Pin 11. Actually, I think you're missing the. I think if you move actually everything to the right, it's gonna work because you see it's column-wise. Like the energy is gonna flow column-wise. So the pin 11 should be like in the same column as any pole of the resistor. And then the resistor should feed the larger leg. You see like here, for example, this feeds the entire column. The pin is gonna activate the resistor. The resistor still has energy, and then it's gonna leave the energy for this column. And then it's gonna feed this positive side.
Okay.
So make sure like the column matches. You know what I mean?
And it's not matching?
No, I think it's, for example, here, we should move this.
To the right?
Exactly. Wait, I don't want to break it. Oh. It's kind of stuck. Wait. Oh my God.
I didn't realize I put it so.
No, but it shouldn't. We're in trouble. Actually, let's not move it. Just put it there. And this should be, see, this is the larger leg. So this should be here because it's the same column.
Mm-hmm.
And then, wait, my pose is
Got it.
terrible. Yeah, so try to like put it a little bit deep, but like deeper. But it should work like that. You guys are ready with the circuit? Is already working? Great.
It's on. The LED is on.
It's on already?
Yeah. And there's no code.
Wait, what did actually, what? So wait, upload this. Maybe there was some code uploaded in the Arduino already, so that might be.
And it's not even selected.
What? That's crazy. Compiling. There you go. Yeah. Probably there was some code uploaded in the Arduino before, like from the previous workshop.
Yeah.
Okay, so I'm gonna open up the. So if you guys go to the Notion page, let me see. This link, which is actually should be in the Explore Hub for you. You're gonna find like the link to this site, which you have the intro materials for information, and then the Arduino projects, and I'm gonna upload right here. So here you have the connection just in case. And then you're gonna find in code, which I'm gonna upload it now for you guys to work with the. So the way we're gonna be doing it, the entire workshop series, not just today, is like we do one project, I explain it, then we set up the circuit, and then I upload like the code or the column code, like the sketch, and then some to-dos for you guys to implement it. I think that's, if that makes sense. Oh my. So let's see if you can see it now. Yeah. So now you can see like the project1.ino, and I don't know why it doesn't allow to download it, but if it doesn't, just hit Ctrl A, select the entire code, and paste it in your Arduino IDE sketch, whatever project you open.
Can I see that code?
Yep.
Because I need to type it. I don't have internet.
To the Explore Hub? Why? No, but you can type, for example, you can go, I think if you type go.fiu Explore Hub. Is go.fiu go.fiu.edu/Explore Hub, like that. So you should see something like this in that file. Bless you. So to kind of get started with the coding part, let's say, of the Arduino, so you can see this is going to be our main, the main column of any sketch that we're going to run, anything that we're going to like run in our Arduino board. So it's very important to know that on top of the file, we're going to be defining all the variables that we're going to be using, both the constant variables that are not going to change and the variables that are going to change throughout the program. And we also have the void setup function, which is basically the first thing that it runs in a robot, because it's all the configuration file and everything, all the steps that the robot needs to perform before actually doing stuff. And where the magic comes is in our void loop function. So they should have the same name all the time, like the void setup and the void loop are going to be in all projects. And basically here is going to be the logic of what we're going to do. We're like turning on the LED, everything. And and things about C++, which is the language that we're going to be using. And I don't know if you guys have any background in programming. You told me yes, no, at all, zero, don't worry. Do you have a little bit? You guys have any background? Yeah. What language? JavaScript and Python, okay. You? Java and Python. You, my friend, over there? You have any programming background? Okay, great, awesome. So here we're going to be defining a variable in C++ is typed, so we have to specify what type of variable we're going to be using. In this case, it's going to be an integer, which is defined by int. We are going to be here defining the LED pin, which is going to be, in this case, 11. As you can see, it should match the circuit, right? Physically where that LED is connected into our Arduino board. Make sure it always matches. Let me see. It's not a port, it's like the pin. Yeah, so it's sort of where you're gonna be setting up like the energy stuff. You're telling basically Arduino where to control the stuff. And in the void setup here, void is used for functions that do not expect any return type. So we're just gonna be calling like functions and doing stuff. You don't have to return anything. And void is just to say like do stuff. And in this case, we're going to be using a very important function. As you can see here, is going to be always like the description of every function that we're going to be like we're going to need for each project. In this case, in the setup, we always use the pin mode. In that way, we are telling Arduino, okay, we want to use that pin, the pin 11, as an output component. And recalling what we saw in the previous slides, we're going to have input and output components, meaning output components are going to be those that only perform tasks and not going to read values, are just going to do stuff for us. And we could say, for example, just a simple example, like move an arm, what it could be, like input or output? Output. So, and then, for example, touching a button, what is that, input or output? Input, exactly. So in this case, we're going to be using the output for turning on and turning off the LED. That's very important to include this line. If not, it's not going to work because you're telling Arduino, make sure that all the things related to pin 11 are going to work, right? And in the void loop, here I want you guys to just turn on the LED and using this function, which is a digital write, which expects the pin number, which is defined by this variable. And it's going to be, as we saw before, it's going to be either high or low. It's going to take either 1 or 0. So recall that high and 1 stands for maximum power. So if you want to turn on the LED, you need to make sure that you pass high as an argument. And otherwise, same with low. And something very important in scripting in general, so for example, if you program Python, you use time.sleep to pause the script. If you need, for example, the robot to have some rest, let's say, or you want to produce some effects on some of components, we're going to see that it's very important to produce effects on the LED, the fade in, the fade out effects. So the delay, what it does is basically freezing the execution time, right? This happens on runtime. This is not on compile time. This happens on execution time or runtime. And here, basically, I want you guys to use this function, turning on the LED with what I just said. And then here, wait for 1 second with the LED turn on. And then after 1 second, turn it off again, wait 1 second, and then remember that, as the name says, it's going to be a loop. So after this line, it's going to come all over to the top again, and again. And that's very important because if we have, it's not a loop, then it's going to do it once and then our robot will shut down. So we want to make sure that that happens automatically in Arduino, but in general, you're probably going to need a while loop or something to keep it running. So you guys try to do that, and then we see the solution. when you guys are done, like you can click this icon, like the arrow pointing to the right, which stands for like uploading it. And you're gonna see like a signaling saying it's compiling the code because it's checking if there are compiling errors at the beginning. And then if it's okay, if the test pass, then it's gonna physically upload that code to the Arduino and then should turn on and turn off the LED if that works. No way. Did you guys could finish this? Could finish? Yeah? So how is the code? Anyone wants a volunteer here? Wants to say how is the solution? So we can test it. Okay. Okay. Great. Hi. Like this?
Yeah.
Okay. Did you guys think it's okay or not? That solution? Yeah? Actually, indeed, it is correct. So, well done. So, if you guys couldn't do it, try doing that code, writing out, and test it, mainly to see if your Arduino is working properly, probably. So this solution should work. So again, you're going to specify here the LED that you're using. Make sure again that always, yeah, sorry.
So just out of curiosity, is low and high, like, are they constant hints?
Exactly.
Representing 0 and 5?
Yeah, behind the scenes.
So out of curiosity, if I replace either of them with 0 or 5, will it do the same thing?
Yeah.
Okay.
So you just use like high or low because it's more like human readable, like to maintain the code. But yeah, good catch. High is going to be 1 and low is going to be 0. And it's going to work. But make sure you always match the pins that you set up here with the circuit, because if not, it's not going to work.
So basically it's turning on, waiting for 1 second,
Hmm.
turn it off, waiting for 1 second, and then loops.
Exactly. 1 second here and then turns on again, waits, turns off, waits. Okay, that was the first one. So to get started. So and actually if you play around with the code, so if you put this like lower numbers, you're gonna see that it's gonna be blinking faster, right? So if you do 250 milliseconds, it's gonna be much faster. So if you guys want to try that, take it a shot. And Great. So now, for the project 2, again, same circuit. We're just going to be doing the code. Same circuit, you don't need to change anything. We're going to just change our logic. We're going to start playing with the code a little bit more. And same, we're going to be using pin 11. This doesn't change. The setup, we don't have any more components to use. In this case, I want you guys to turn on, and then turn off, and then add 2 more patterns. Like this is just one pattern, waiting for 1 second. I want you guys to play around with the delay function and use different like wait times, sort of. So try to do that, and then we go over it. And again, here on the right, you're always going to have your functions. And by the way, I forgot, like the digital write is for digital pins, and the first argument is going to be the pin number. In this case, if you pass the variable, it's going to be holding 11. So that's important. If you guys need help with something, please let me know. Yes.
So how do I connect the notes to my computer so I can upload the code?
What, sorry? Say that again.
Sorry, I dropped. How do I connect it to my computer?
Oh, so you need
Yeah, I'm trying to look for it.
this one.
Okay, thank you.
You're welcome. Yep.
Now, ¿qué necesito ahora poner? ¿Más digital write or digital write and delay? ¿Qué necesito poner? Porque aquí le he bajado 50, pero es en la primera. Ahora, en este ejercicio, necesito poner otra vez un digital write con high y un delay más otro digital write.
Exactly. So depends on how you do it. The design that you want to give it is fine. Your approach, both of them are fine. But in this case, we are not like making it more complex. But if you use, do you know arrays?
Which one?
The arrays. What is an array in programming?
No.
Okay, so you're holding a lot of variables all together, right? So let's say you define an array, which is like a container.
Yeah, an array.
An array, yeah. Or a list in Python, yeah. So you have 1,500 and 250. If you iterate over it, you just need to write 2 digital writes and take the variable that is holding in that time in the array. But in this case, you need to write like 6 in total, 6 digital writes.
So we already have 2.
2, yeah. So you have 2, which should be both 1,000. So now you need to create 2 more patterns.
Okay. So
Like turning on, turning off is just one pattern. I need to do again like the same, 2 times, basically, with different times. How is it going here? Good? Here? 1,000, yeah. If you need help, let me know. Is that pointing only to the screen?
Yeah.
Okay.
Yeah.
I'm not appearing? Just kidding.
This is educational content.
No, yeah, but
Modeling shoot?
sure.
You can have little kiss chocolates around too.
My God.
Ya se está poniendo roja otra vez.
De verdad. Okay. So this could be a solution. If you guys did something else, it's fine. But basically, here we are repeating the process over and over again. We are turning on, turning off. We are just changing the pattern, right? Now it should be faster, and now it should be even faster, and then reset. So make sure to write a code and make sure that it runs. So I see LED is blinking, so that's fine. It worked there. Yeah, so great. Let me see. Okay, this is just to implement. Actually, there's no, for this one, it's no exercise, but to see what's going on. So for the project, this is the 2 blinking patterns. So I'm gonna upload project to remaster. So if you guys go to project 2, you're gonna see now the new code, which is gonna be the same as you just did, which is actually your question. How can we reduce the logic and how we can make the code cleaner, let's say. And this is very important for software practices. Actually, if you see, and if you visit the Explore Hub, which should be uploaded now, this particular file, you're going to see now that we created a custom function besides setup and loop that is called void delay pattern, and then it takes an int pattern as a parameter, and you're going to be calling it from the void loop, which is, remember, is the main function that controls everything. So from our backbone, we are calling the delay pattern function. We are using as well a for loop, which is a is an iteration like practice in programming, right? So you define the first part of the for loop structure. For those that are not very familiar with C++, what actually Java is very similar, but you define the type again in pattern. You're just gonna define a variable that you're gonna be using in that loop, not outside that loop. Define in pattern 1, and then you want the loop to go all over it until pattern hits 3 inclusive, because we are saying in pattern equals 1, semicolon, pattern less than or equal to 3. So in that case is 3 inclusive, and then the third element of the for loop is basically by how much you want to increase the pattern variable every time the loop finishes. So after iterating the first one, it's going to be 2, and then it's going to be 3, and then it cuts because 4 doesn't meet the condition, that pattern being less than or equal to 3. So if you guys see what's going on, so you call it again digital write. That's the same as we did the previous one with the patterns, but now you're calling the function that we wrote here. And you're passing it this variable, which is going to be either 1, 2, or 3. 3 for like different times of the iteration, right? And the first iteration is going to be 1, then it's going to be 2, and then it's going to be 3. And here, if we delve into the function that we wrote, so it's taking pattern, which is being passed here. Remember, for example, now this is going to be 1, the first iteration, and you're going to say if pattern equals 1, which this is a conditional statement in programming, then if it's 1, it's going to go into the statement that is defined between the brackets, right? Here, and then here you define everything that you want to do if pattern equals 1. In this case, you want to delay the execution time by 1 second. The same with 2 for 500 milliseconds. And then the same for 3 to 50 milliseconds. So that's another way of implementing what we did before in the previous example. If you guys want to implement it, feel free to do it, to play around with the code. This is like new, we're starting to introduce new tools, programming tools that we're going to be using in the next exercises and also workshops particularly. And make sure that you incorporate the if-else conditionals and also the for loops. That's very, very important in programming in general, but for this as well. So if you guys, I'm going to just move on with the next one, but if you want to visit this code, it's in the Explore Hub. If you go to the project number,
We use else if instead of if.
it's going to work.
Yeah, right.
Yep, that's a good catch as well. Yeah, because we have the if, now that you ask, it's going to be if, we have else if, and then we have else. And the difference is that, for example, let's say pattern is 1, right? Like the first iteration, pattern is 1. Then if pattern is 1, yeah, it's going to execute it, but it's going to waste time checking it again if it's 2 or 3. But we know for sure that it's going to be 1. Then you could use, as you said, else if, so that it just skips that time and you actually saving time. But for this code, it's not going to change probably the efficiency. But yeah, it's a good observation. Okay, so we're going to move with the next one. So for project number 4, my bad. Actually, before we have a topic, yeah, that's very important. So we saw binary signaling, which was either 0 or 1, and that's for digital signals. But another special case for digital signals, we also have the pulse width modulation, which is also referred as PWM. You're going to see it very often. And actually, this is very important because it allows to control output components within a continuous range. It's not going to be either 0 or 1 anymore. It's going to be any number, any value, integer, between 0 and 255. That's how the Arduino IDE handles it. And in electricity, again, the same way that it was 0 volts or 5 volts for the maximum power, it's going to be anything between 0 and 5 volts. So what you guys think? the ground pin again, not directly to the LED, but instead to the row first, and then another cable from the row for the free. Do you guys need help or anything? Let me know, right? Hello, hello guys.
I know we're in the late, but is there anything that we could do at the moment for the Arduino thing?
You guys know anything about Arduino?
I haven't like actively like genuinely for a project used it, but I've
Okay.
like had like workshops.
Okay, yeah. Feel free to grab one. We are doing actually the last because this finishes at 6. So because we already did like all the explanation about the
Yeah.
initial concepts. But if you have anything like any knowledge, you can try to jump into the like last project for the day if you want, or if not, then just
Just observe.
observe or come directly to the next workshop. Yeah, but you can, of course, you can stay.
When would that be?
Like how long?
Yeah, no, like when would that be? Like next workshop?
Oh, next workshop, actually it's gonna change. We're gonna be doing a recap what we saw today, so it should be fine, and then we're gonna add a lot of other concepts, analog signals,
Okay, that's fine.
if that sounds familiar.
Okay.
Yeah. Yep.
Set up here.
Okay. Hope that works, because I cannot tell the. Yeah.
We followed this. Where would this be?
Oh no. Actually, I forgot to crop the image for the Notion page, but it should be like.
Okay, so it's just up.
It's just the LEDs. Yeah.
So up to the
Exactly, up to here.
Okay, so none of this.
No, none of that. My bad.
Okay.
That's on my end. So could you guys finish with the circuit or not yet? Yeah? Just to see if we can jump onto the code. Yeah? Okay. If not, you can check it in the Explore Hub. And I noticed that in the Explore Hub, I have like another diagram that it has not only the 3 LEDs, but also like some random component that we're not going to use. So just stick to the 3 LEDs for now. So moving on to the code, which I uploaded it in the Explore Hub. No, not yet. So now you can check your Explore Hub again. For project 5, you can copy and paste or download if it allows you. And then you should see this. So you guys just need to implement where it says the to-do and the instructions are there. But it should be like a simulation of a traffic light. You're going to be using both functions, the digital write and the analog write. So this is a recap of what we did today, basically, an integration. Here I'm just going to add a hint, so digital write. And make sure, guys, that the pins matches these three variables in your circuit. And adding the setup function here, you need to do it as well with the pin mode that we saw. Actually, let me put the functions that you need here. Do you guys understand the structure or are lost or something of the tasks? Let me know if you need help or something. I mean, you need to do everything almost from scratch, so you might be stuck a little bit, which is good. for the last 5 minutes, we can do it all together. So you can guys test it and see how it works. Thank you. Thanks for coming. Actually, let's start implementing it. So. So can anyone tell me for the setup what we have to put there?
Well, for the setup, we have to pin mode each of the LEDs,
Okay,
and they're all output.
great. Awesome. So we're gonna just kind of do it. Exactly. So in the setup, we're just saying, okay, the 3 LEDs are gonna be output components. And for the first part of the loop, what is it asking for? And how can you implement it? Did you guys do the first part? Or not yet?
We could do a for loop with for int I equals 0, I is less than 4, I plus plus, and the digital right green LED high, and delay 100 each.
Repeat that again. So it could be for loop from 1 to 4.
Yeah, for loop up to 4.
Up to 4, and then what do you do inside the for loop?
Digital right, green LED, high,
Okay. Mm-hmm.
and delay 100.
Okay. Wouldn't it be easier to just turn on and delay of 4 seconds?
Yeah.
Yeah. What do you think? Like, why would you, unless you want to do some specific behavior between each second, which is not required, but I mean, you want to use like for end.
I don't know. I just saw something in the comments that mentioned a for loop, but I think I was mixing it up with.
Probably the fading. Oh yeah, the other ones. Yeah.
I was wondering that too. I was like,
Oh, you mean this one? Oh, my bad. Actually, yes. Yeah. You mean this structure?
yes,
Oh, okay. So how it could be?
yes, that one.
Digital right?
Right, 5 cycles of 200 milliseconds.
Okay, so green. And here is what value?
Oh, high.
High, okay. And then for the other line, actually, it's low.
Oh, low.
First it starts with turn off.
Oh, yeah.
Low. Or 0. You want to try 0 to see if it works? Then a delay, right?
For 200 milliseconds.
Actually, 100.
100.
Because it's going to be turn off 100 milliseconds, turn on 100 milliseconds. So 200 in total.
200 total.
Yeah, for the cycle. Here it says like 5 cycles of 200 each in total. That would be delay 100, digital right the same. But in this case, we want the green LED to turn on, right? Again, delay of 100 milliseconds. And there we have the first part. Red and actually, first we need to here, because it says ensure red and yellow are off. So what do we have to? 2 lines of code.
Digital right, red, low, and yellow low.
Perfect. Right. So we wait for 4 seconds. So let's turn on for 4 seconds. Here, digital. Right. I'm gonna say the green one because it is asking for to turn it on. And then for the fade in and fade out effect, how would you do that?
I would analog right,
Analog right.
yellow LED with brightness,
Great.
and then delay.
Delay of how much? 10.
Same thing for the fade.
For the fade out?
Darkness, yeah.
Okay. Analog right. Yellow. And then here where it goes again for the second parameter.
Brightness.
Brightness. Okay. Great. And then
Delay 10.
delay of 10. Awesome. And guys, for the last part, anyone else that wants to say what the implementation could be? There at the back? No? No, she's focused. You want to say it? Okay. Just go.
Digital lights, red LED, high, and then a delay of
High. A delay of how much?
5,000.
Oh, actually, we should put it like above, right?
Of the delay.
Yeah.
And then to ensure that they're, do we have to, are they already off, or do we ensure
We should
they're off?
turn them off
Okay.
manually.
Yeah, we do digital right
Where? After or before the delay?
before the delay.
Great. Digital right.
Digital right.
You tell me.
Yellow and green LED low.
Yellow, so you want 2 lines of code.
Yeah.
Okay. Digital right. Green LED. You're shutting off the thing. Great. And then for intermediate state, what do you do?
I turn off green. Oh wait, no, green is already.
It's already off.
It's already off.
Yeah.
Digital right, red LED high, and well, isn't the red LED already on?
It is.
Okay, so can we omit that, or is it like?
We can omit that. Yeah.
Then in that case, I just turn on yellow LED.
Okay, so we just turn on the yellow. I'm just following your step, man. Okay, high. So we turn on red and yellow on together for 2 seconds.
Yeah.
And that's it. Test it like that. So I think it should work. Wait.
There's a little bit of a.
There's a problem?
Yeah, it's not turning on. Is it because did we push it in? The ground wire isn't even in.
Let me see. What happened?
The ground wire wasn't even in.
Okay.
Minecraft videos.
That's why I
He
was.
doesn't anymore. Now he just does like rich flex stuff. No, literally.
It's working?
Let's see. The red turns on for 5 seconds. Flashes. Yellow and red are on. Green turns on with.
Oh, actually, there's
There's a bit of an issue.
is what we implemented or something else?
Let me check. So,
It might be. It might be. I don't know.
red is supposed to be on first.
I'll be right back. You watch my stuff for 2 seconds. I'll be right back.
So it's the last part that is failing? Let's debug it. This is actually good. Yeah. You have a... Not turning on? What's going on? Try to identify the issue. Hey, what's up, bro? How's it going?
Did I do this right? The sketch?
The sketch, let me see. So
No, sorry, this is the wrong one.
I think it's fine. You're missing the main wire from the ground
Oh.
to here,
Okay, so how do I
to
do
the
that?
ground. So you need to add one cable. Yeah, so you connect the ground.
Over here?
Yep, anywhere, any ground. Yeah, and now you connect it to the row. To the row, like here in the that one. Yeah, it could be there. There you go. Great.
Oh, wait. There's a bug. Never mind. Hang on.
Actually, yours is working well, I think. And again, comes back. It's working.
Oh, okay. Oh, there's.
Did you follow that code, or you did something else?
No, I followed it.
Okay, man. So.
I just, but I mean, I basically just did it myself without having to.
Okay. I mean, maybe it should work. Could you? Or it's buggy.
It's a little funky. So it should be.
So it's.
Green should be starting first.
Yeah,
but
that's
when
what I was thinking.
green should be starting first, but when I upload it, look, it
It starts with red.
it starts with red. It's with red,
What?
and then it moves to yellow.
Digital. Wait. Go up. Green LED. Wait, you know why? Maybe the pins are matching the code.
Oh wait, maybe the pin. Wait, hold on. There's no way.
Maybe the pins are not. Probably the pins.
Oh, wait, let me check this.
Could you hear? Or.
Yeah.
Yep.
I wasn't able to follow along as fast as you guys did.
No, I know. It's this one is. Why is it? Wait, let me.
Okay, so green.
It's shut down. So what's the pins or no?
They're checking now.
They're checking. Okay. I think if you copy that code, it should work at first glance. Actually, let me see. Ground. Let me help you with. So this is the. I see it here.
Nothing seems wrong with the code.
Nothing seems wrong. That's the thing.
That's the problem.
Okay, so it starts with red for whatever reason. Then it blinks red.
11. Hmm?
Is it stuck?
Which? What, this? It looked like it. I could take it out. So it's fine.